All right, let's make this real with another example of using MapReduce to solve a real problem. What we're going to try to figure out is how many of each rating type exists in the Movie Lens rating dataset. So how many 1-star ratings are there? How many 2 stars, 3 stars, 4 stars, and 5 stars? And we'll figure out what the distribution of those ratings really are. Just how picky are people? At least how picky were they in 1998 when this dataset was created? So the art here is turning this problem into a MapReduce problem. Anytime that we need to try to use MapReduce for an analysis like this, you need to figure out how to assemble mappers and reducers in such a way that produces the result that you want. And I'm going to be honest with you, sometimes it's not easy to try to force a problem into this way of thinking. And that's a big reason why other frameworks like Spark or Hive or other ways of processing SQL-style queries have become a little bit more popular than just writing raw MapReduce code. But still, if you can easily express something in terms of mapping and reducing, this can sometimes be the most efficient way of doing it. So you have to think creatively sometimes, and that's what we're going to do here. So here's the basic strategy on how we're going to tackle this problem. So here again, we have a little snapshot of the raw input data from the Movie Lens dataset. It's just each line contains a specific rating, and each column of that rating contains a user ID, a movie ID, a rating, and a timestamp. Okay, so what we're trying to do is count up the number of each rating type. So again, the first thing our mapper needs to do is just extract the information we care about and throw away the stuff that we don't care about. Now in this case, the only thing we care about are the ratings themselves, because we just want to count up how many 3s there are, how many 1s there are. So all we're going to do is extract the rating itself, for this example, 3, and then the number 1. And the idea here is that we're going to get all these key value pairs where the keys are the specific ratings and the values are all the number 1. And then when we reduce and aggregate all the different values for a given rating, a different key, we can just add up all those ones together to get the final count of how many times that rating occurred. Okay, so the trick here is we're going to map the input data into key value pairs where the key is the rating and the value is the number 1. The shuffle and sort operation that MapReduce does under the hood will then collect all the 1s that were associated with every individual rating, and then our reducer can count up all those 1s and add them together. So, for example, if we were to go through all the shuffle and sort all the 1 keys, all the 1-star ratings, we end up with the 2 values, a 1 and a 1. We only saw the rating 4 once in this specific example, so we only receive a single 1 value there, and our reducer can add them all up to tell us the final result that we want, that 1-star ratings, there were 2 1-star ratings, 2 2-star ratings, 2 3-star ratings, and 1 4-star rating. So, how do we actually turn this into code? So again, we're going to use streaming to actually cheat a little bit and use Python to write our mappers and reducers, because it's going to be a lot simpler. Now, I know a lot of you might be new to programming, and so I'm going to go slowly here and explain what's going on here. Now, if you are new to programming, don't get discouraged here. There's a lot of stuff you can do with Hadoop that does not require programming, so you might just want to watch here as opposed to following along when we try to go through this later and just sort of absorb it. Hopefully, even if you haven't coded before, you can see that it's not quite as mystical as you thought. So again, our mapper just needs to extract from each input line the rating itself and the number 1. So we want to extract the key of the rating and a value of 1. So in Python, here's what a function looks like in Python. So def is just how we say we're defining a function signature in Python. We're going to name this function mapper get ratings, so we can later invoke this function by that name. And mappers receive 3 parameters in Python when we're using the mrjob package that we'll talk about later. First of all, it receives a self object that just is the object instance that this is contained within. That's not going to mean anything to people that haven't done object-oriented programming before, but we don't really need it for what we're doing right now anyway, so let's gloss over that right now. The second value is going to be usually unused in the case of a mapper. But if you're chaining MapReduce stages together, this might be a key coming in from a reducer that came before you. But for this example, all we care about is this third value, which we're going to name line. And this is each input line of data that's coming in. So for the first mapper that we write in our MapReduce job, all it's going to receive is this third parameter, and you can call it whatever you want. We're calling it line, just, because it is a line of data, so we may as well name it something meaningful, and that's what we'll refer to that input line within the function. We then have a colon saying that the function body continues from here, and in Python's a little bit weird because white space matters. So the fact that we indented these next two lines, there's a little tab there, means that these are all part of this function. So this syntax means I'm creating what's called a tuple. Anything that's, a list of stuff contained in parentheses is just a list of things, and in Python those can contain pretty much anything. So we're going to extract 4 variables, and we're going to name them user ID, movie ID, rating, and timestamp. And this is going to come out of the split operation on the input line, and we're going to split it on a tab character. So that's what this means. It means that we're going to take the input line string, split it up by tab characters, because I happen to know this is tab delimited data, and assign each resulting field to these variables. So the first column, we're going to take each line, split it up by tabs. First result will go into the user ID, second result will go to the movie ID, third into the rating, and fourth into timestamp. Now again, we're throwing away everything but the rating. So yield means this is what our mapper is going to give up when it goes back to the MapReduce framework. So given an input line, it's going to give back a little key value pair where the key is the rating and the value is 1. So the first value that we return is the key, comma, then the value. And it's worth noting that this value could also be a list of stuff, a tuple, if you will, but we don't need that yet. So again, stare at this a little bit if you need to. It's actually pretty straightforward what it's doing. This little block of Python code is just a function that takes each input line, splits it up by tab characters, sucks out the rating along with everything else, and then outputs that rating and the number 1 as the key value pair for each input line. Okay? And from there, the results all get passed into the MapReduce framework, which does shuffle and sort for us, and then we just have to write the reducer. So let's take a look at that next. So here's what our reducer looks like. It's even less complicated. So again, def means that we're just going to define a function in Python. We're going to name this function reducer count ratings, and it also receives 3 input values. So again, the self object, the instance of this object that we're running within. Again, don't need it right now, so don't worry about it. Don't need to understand object-oriented programming really to use this stuff. Then key, that's going to be, our reducer function will be called once for each unique key. So for a given call, it's going to receive a key. Maybe it's the rating value 1, maybe it's the rating value 2, maybe it's the rating value 3, right? So on and so forth. And then values is going to be a list of all of the values associated with that key. Now, technically, this is what's called an iterable value, an iterator. So it's not really an array per se, if you want to get all technical. It's a list of values that you step through one at a time. And that way, the MapReduce framework can just feed in values as they're needed as you're processing them, as opposed to needing to copy all of the values for a given key into memory at once. And that just makes things even more scalable. So all our reducer count ratings function is going to do is output, as a final output, the key, which is going to be a rating from 1 to 5, and the sum of all the values associated with that key. So it's going to count up all the 1 values that were reduced together for each rating type and add them all up. So sum just takes this iterator and iterates through the entire thing, counting them up as it goes. And the final result will end up being each individual key, each rating type, and the number of times that rating occurred. It's just that simple. So let's put it all together. There's some framework that has to go around it all. So here's a complete Python MapReduce script. This is the whole thing. This is it. This is all the code needed to actually run MapReduce on the movie lens dataset and figure out like a histogram of all the rating types. So a couple of things in Python, since we're actually we're going to be using a package called MRJob. And this is basically a way to very quickly write MapReduce jobs in Python. It abstracts away a lot of the complexity of dealing with the streaming interface to MapReduce for you. So you don't have to really think about how streaming works. It takes care of all that for you already. But in order to use this package, we do need to import from the MRJob library both the MRJob and MRStep names so that we can actually use them within our script. And that's what those 2 lines are doing. Now, each MR job, each job that we do is going to be wrapped inside what we call a class. And this is just a way of organizing a bunch of functions and data together into a single entity. So in this case, we're going to be organizing a mapper function and a reducer function and a definition of what those functions are into a single job called ratings breakdown. Okay, so that's all we're saying here. This parentheses MR job just means that ratings breakdown inherits from the MR job class. It's part of the MR job package. So it just means that our ratings breakdown class has all the capabilities defined by MR job. Okay, 3 functions within this ratings breakdown class. One is steps, and what this does is it tells the framework what functions are used for mappers and reducers in our job. So this is just saying that we're going to have a single step, that's a single MapReduce phase, where the mapper is our mapper get ratings function and the reducer is the reducer count ratings function. And then we need to define what those functions are. These are the same exact functions we looked at earlier in this lecture. So we then define our mapper, which again takes each input line, breaks it out by tab characters, and returns a key value pair of the rating and the number 1. And then we define our reducer, which takes each unique key and a list of all the values, all the ones associated with that key, and returns the rating and the number of times that rating occurred. Okay. Finally, we have this little line that you'll see in every MR job script that you ever write. And all this is really doing is saying that if we're executing this script from a command line, go ahead and kick this job off. Otherwise, well, I'm not sure how much depth I want to get into here, but basically this same script might be being run within a streaming context, right? So if you're just interested in running a specific mapper or a reducer as part of the streaming on each individual node, you don't want to actually kick off the whole thing. And this is just a little syntactical trick for allowing us to use the same script both to kick off the job as a whole and also to kick off individual mappers and reducers on the individual nodes on your cluster. Okay? So, if you do change the name of your class to something else, you would need to change that name here as well. But otherwise, this is all just boilerplate. Okay, so that is an entire MR job script in Python that would use MapReduce streaming to actually execute across a cluster. So up next, let's actually run it. We're going to need to install a few things on our little Hadoop sandbox first, so let's get those out of the way next. And after that, we'll actually run this thing and see what it does.